From the beautiful South Studios of Way Happy, this is Mr. Meyer in 3.25. Wait, what? That's not in the book. That's right. This is part of 3.2 that I think should have its own section. So I'm going to call it 3.25. It is mixture problems and what always gives kids fits when they are trying to solve them. So here's the way that I do it. I end up making myself a little table, as you can see right there on the screen. And what I do is I put the amount of units in one, then the percent or the money value in the other, and then I multiply that together, and that's the total for that amount. And so you can see I do that for both items, and then I have to add going down. So the big trick here is that you will add these numbers right here, and these numbers right here will add. You never add the middle column, and you multiply across. So going across, you multiply. And that's what we'll be looking at on this section. So let me kind of do a couple of examples, help you how I did them when I first started to learn them, when they finally made sense. So you can see this says how many milligrams of metal containing 45% nickel must be combined with 6 milligrams of pure nickel to create 78% nickel. So I'm going to have the number here, then the percentage, and then I don't know what you want to call it, the units or something. I have a hard time labeling that column. And so what I will do now is I will say, all right, I don't know how many milligrams of 45% nickel that I'm going to use. So let's use our variable x of 45%. Oops, I didn't want a snipping tool. Of 45%, so I'm going to write that as 0.45 in decimal form, is going to get mixed with 6 milligrams of 78%. Oh, no, I'm sorry, pure nickel, 100%. And that's going to create a final mixture of 78%. Now that's why you can't add those straight down, because it doesn't make sense. There's more of one than the other, so you can't add down. So you always got to know what that final percentage is going to be. Now, remember, we add straight down. So like adding down here, I'm going to have 6 plus X milligrams of metal, whatever it is, because I already have 6. Add some more, and whatever I have is going to be 6 plus X. Going across, remember you multiply. So this would be 0.45x, and 6 times 1 is just 6. And here's my favorite part right here, the money cell. That's the guy that's going to be right? This is the guy that's going to have all the answers. And what do I mean by that is when we add this way, multiply that way, it should equal when you add this way. So you have a nice little system. You're saying when I multiply 6 plus x times 0.78, when I multiply that together, it should equal when I add 0.45x plus 6. Those two things should be equal in order for my chart to work. And lo and behold, that's how I will solve. So let's see, I got to figure out what 0.78 is of times 6. So let me see. I have a calculator laying here. Look like 4.68. 4.68 plus 0.78x is equal to 0.45x plus 6. Let me make sure I typed it in right. Yes, that looks good. And then I will subtract over, get the x's together if you so wish. So minus 0.45x from both sides. And heck, I might as well subtract over this 468 also. And when I do that, I get, what is that, 33x. So 0.33x equals what's left there. That's like if that was money, $6 and $4.68, you'd get like $1.32 back. So you'd get $1.32. And now I just need to take that $1.32 and divide it. $1.32 divided by 0.33. And you are looking at 4. Guess I could have figured that out. 4. And there's your solution. You need 4 milligrams of 45% in order to get 78% mixture of nickel or alloy or whatever you want to call it. Nice? So there you go. You fill in this chart with whatever you got. Let's try another one. So as I scroll down here to this one, I'm going to do the exact same thing. I got number, I got percentage, I got units, I guess I'll call it. So the first one, I have 5 fluid ounces of 2%. So 5 fluid ounces of 2% is written as 0.02, is mixed with 11 fluid ounces of 66%. Find the concentration of the new mixture. So again, adding straight down, this is 66. I'm sorry, this is 16. And multiplying across, if I take 0.02 times 5, that would get me 10. But with the decimal would be 0.1. And 0.66 times 11. Let's grab that boy. And that is 7.26. And now I add that down, so that's 7.36. So that's how many units of this chemical we have. And this is the total number. And so we are just going to divide that and expect a number somewhere between 66 and 2, right? So as I divide that, I will take 7.36 of acid divided by 16, and that will get me the percentage of what we have. So 7.36 divided by 16 is 0.46, I believe, or 46% solution. So you can see the chart can always give me the beauty answers. What about this one? The seniors have a 50-gallon carton of orange juice with 6% pulp. How much orange juice with no pulp should be mixed to make 3%? All right. So we have number, then we have percent, and then we have units of orange juice, I guess it would be, or units of orange. So they have 50 gallons of 6%. So when you multiply that together, right, you would get 3. 3 units of oranges is what I think of it as. It's like 3 oranges or something. It's not really what it is, but that's what it feels like to me. Then how many gallons, I don't know, of 100%, oh no, of 0%, right, with no pulp should be mixed. So this is 0, should be mixed in order to get 3%. So I have 50 plus x here because you add straight down. I have 3 here, and now I can solve for this, right? I can say that 50 plus x times 0.03, that's the multiplier, I shouldn't have filled in the money spot yet, is equal to 0 plus 3. And now I will solve. So 0.03 times 50, that's what, 1.5 plus 0.03x is equal to 3. Then I will subtract the 1.5 over, and you'll get 3 minus 1.5 happens to be 1.5. And then you divide by 0.03, and that would be 150 over 3, or 50. So that says add 50 gallons of pulp-free orange juice in order to make yourself a mixture that is 3%. Now I think about it, that kind of made sense and was kind of silly. But that's good that the math worked out, because if I did 50 gallons of 06 and then I do 50 gallons of none, then you'll have 100 gallons of 0.3, because that's really the mean of the two. All right, let me ask you a question, and I'll be right back. All right, beautiful work. Now let's try this one here. Miranda has a knick-knack shop, and she has Hawaiian pineapple mix, and she wants to mix it with strawberries, and she wants to make this great surprise fruit mix. She wants 300 kilograms of it because that's what she's going to bag and sell, and she wants it to be worth $7. So here we go. Again, I have the number or the weight or whatever. Here I have money or percent, so this time it's money. And then right here I have the units or the total or whatever you want to call it for that item. So I don't know how much pineapple she wants to use, but she wants 5 kilograms. So again, remember, multiplying across, that's 5x. Then I don't know how much strawberries she has, but I know they're worth 8. So that's 8y when you multiply across. Now, the good news is I do know some totals. They did tell me they want 300 kilograms of 7% mixture. Or I'm sorry, $7 mixture. So that kind of helps out a little bit, right? So remember what the rules is, like adding down should happen. So we know that we have x plus y equals 300. And the other equation I know this multiplied together equals this added down. So 300 times 7 should equal 5x plus 8y. Oh, look at that. What do we have? We have ourselves a little system, right? We have x plus y equals 300. And we have 5x plus 8y equals 2,100. So what am I going to do? I'm going to multiply the top. You can do graphing, you can do whatever. And I'm going to obviously do elimination because that's my favorite. So I will multiply all of these by -5, which will make that -5x, that -5y, and this -1500. And when I combine all that together, the x's will cancel. I'll get 3y equals 600. So y is equal to 200. And once I know y is equal to 200 back in this equation, I know that x must be 100 then. Or I can tell her she needs 100 kilograms of pineapple and 200 kilograms of strawberries. And so that's what I would say. Here's your pineapple, get that much, and here's your strawberries, and you are now going to have 300 kilograms of a mixture that is worth $7. So again, this thing will work left and right? It's just awesome the way it works out. How about this? A solution containing 30% chicken broth is to be mixed with a solution containing 50% chicken broth to have a 200 liters of 42%. Well, that's the same thing. I'll at least set it up for you. And you can see, if you can go from there. Number, you have percentage, and you have units or whatever. I still got to find a good name for that. I don't know how much 30%. I don't know how much 50%. If I multiply this together, it's 0.3x, and this is 0.5y. I do know I will have 200 total, so when you add those together, you'll get 200. And I do know it'll be 42%. So my two equations, when you do x plus y equals 200, and you'll have 0.3x plus 0.5y, these added together, need to equal these multiplied. So 0.42 times 200. And I'll let you solve that up because I feel like it was the same as the last. And here is one more, which got crossed out somehow. Maybe not. It says the fish shop has 10 kilograms of dolphin-free tuna and wild salmon, which sells for $8.40. Dolphin-free tuna sells for $8 and salmon sells for $9. How many kilograms are of each one? So again, number, this time it's money, and this time it's unit. And here's my table. And I want to scroll. I wanted to scroll down a little bit. Got a little carried away. There you go. I don't know how much, dolphin-free tuna sells for $8. And the wild salmon sells for $9. We know the total is 10 kilograms, and we know that it is, $8.40? So again, we have an 8x problem, we have a 9y problem. This right here should get our solution. We have x plus y equals 10. We have 8x plus 9y equals 10 times $8.40, so $84. And now you should be able to solve that just like before using any systems you want. And why don't you tell me the answer right now? And I'll see you tomorrow. Stay happy.